Hi there, Mr. Muhammed is here. Revise for checkpoint book. Revise for secondary 1 checkpoint. Unit 3, expressions, equations, and formula. So let's go through this unit. So throughout the exercises, I'm going to explain. This set of exercises say whether each of these is best described as an expression, equation, or formula. Simply, expression has no equal sign in it. As you see here, 5x plus 3 doesn't have any equal, so this is expression. V is equal to IR, so this one is a formula. This is the rule of finding something, so it's formula. 4x plus 1 is 33, since we see equal here, so it's equation. Number 4 is expression. Number 5, it's formula. Physics. Pi r squared, it looks like the formula of area of circle, but since there is no equal, it must be equal to a, then it will be a formula. Now, since there is no equal sign in it, it's just an expression. C is 2 pi r. This is the rule of finding the circumference, so it's formula. Expression, equation, formula. Pythagoras. As we studied in the previous lesson, when you see the same base, we have to add the powers. The same thing is true for variables. For example, here, question 1, we have x to the power of 6 times x to the power of 3. Since they have the same base, the base is x for both of them. Then when we multiply, we just add the powers. The result is x to the power of 9. Question 2, they have the same base again. We add the powers, but when we add 6 with negative 1, 6 plus negative 2, it will be 4. So the result is y to the power of 4. Number 3, it's division. For division, we subtract the powers. Z to the power of 10 divided by z to the power of 4. That gives z to the power of 6. 10 minus 4 is 6. Number 4, they have the same base. We just add the powers. That gives x to the power of 7. And here, division, subtract the powers. Y to the power of 4. Division, subtract the powers. That gives z to the power of 0. 7 minus 7 is 0, which is just 1. Division, subtract the powers. When a number has two powers, z to the power of 3, all to the power of 3 again, we multiply the powers. This is z to the power of 9. M to the power of 3 divided by m to the power of 5. It's division. We have to subtract 5 from 3. 3 minus 5 is equal to negative 2. So the answer here is m to the power of negative 2, which is also can be written as 1 over m squared. And this one, it's multiplication. We need to add the powers, but just like question 2, since one of the powers is negative, that gives z to the power of 2. Collecting like terms, expanding brackets. Multiply the brackets in these expressions. So to multiply the bracket, we multiply the term which is outside the bracket by all the terms in the bracket. Like the 2 should be multiplied by the x, plus the 2 should be multiplied by the 4. That gives 2x plus 8. Here, the 3 should be multiplied by x, and the 3 should be multiplied by 2 as well. So that gives 3x plus 6. 5 times 2x is 10x minus 5 times 1, 5. it's obvious that we will have 7a plus 35. 10 times 2b will be 20b minus 30. 12x plus 8y, and so on. 2a times 9, that will be 18a, minus 9 times 3, 27b. The rest is homework. Make sure to do it and check your answer. Sometimes we have more than one bracket in an expression. It's also fine. We expand each bracket separately, then add the like terms, because the question says simplify. 4 times x, 4 times 1, plus 5 times x, 5 times 2. Then 4 times x is 4x, plus 4, plus 5x, plus 10. So this is just expanded. The next step is we need to add the like terms. Here are some like terms. 4x is the like term as 5x, and the numbers are also like terms. Then 4x plus 5x. 4x plus 5x is equal to 9x, plus 10 plus 4 is 14. So this is question 11. Now let's do 12. 3 times x, 3x, plus 3 times 2, 6, plus 2 times x, 2x, minus 2. 2 times negative 1 is negative 2. Now we have like terms. 3x and 2x are like terms. 6 and negative 2 are like terms. Then 3x plus 2x is 5x. 6 plus negative 2 will be positive 4. So this is the final answer for question 12. Now let's do 17. 17, 6 times m is equal to 6m minus 12 plus 3m plus 12. Now to simplify this, question 17, 6m minus 12 plus 3m plus 12. Simplify this. 6m and 3m are like terms. Positive and negative 12 are like terms. So that gives 6m plus 3m, 9m. 12 minus 12 is 0. So the final answer of question 17 is just 9m. Question 19. 5 times 2k is 10k, minus 5 times 1, 5, plus 2 times 3k, 6k, plus 2 times 5, 10. Like terms are 10k, 6k, that gives 16k. 10 minus 5 is positive 5. This is the final answer of question 19. And the rest, I know you can do it. It's homework. Let's do one more question, question 20, because here is a negative. So let's see how we deal with such negatives. Question 20, 7 times p will be 7p. 7 times negative 1 is negative 7. Look, negative 2 should be multiplied by 3p and by negative 5. Negative 2 times 3p, that gives negative 6p. Sounds normal so far, but because of this negative, with this one, the result will be positive. Negative 2 times negative 5 is positive 10. So make sure when you have a negative between the brackets, this negative should be multiplied by inside the second bracket to get it correct. Now 7p with negative 6p, what's remaining is just 1p, and it's not necessary to write 1, it's just p. Positive 10 with negative 7 gives positive 3. So question 20 is p plus 3. Factorizing. Factorizing is the opposite of expanding. In expanding, we are removing brackets, but in factorizing questions, we need to put something in brackets and something common outside. Now, since there is no x, so the x cannot be common only between the numbers. 7 and 21 are both multiples of 7. So if we divide them by 7, what's remaining here is just x plus 21 divided 7, 3. Now we factorized. If we multiply the brackets out, we will get 7x plus 21 back again. This is a quick way to check your answer. After you expanding your bracket, if you didn't get the expression again, it means you are not on a right track. Question 2, 4y plus 10. So 4 and 10 are both divisible by 2. So 2 as a common factor goes out. Then what's remaining here? 4y divided by 2. 2y will remain. Plus 10 divided by 2 is 5. Is it completely factorized? Yes, because there is no anything common between 2 and 5. Question 3, 5z minus 20. It's obvious that 5 and 20 are both divisible by 5. What's remaining here is only z minus 4. Here, between 9 and 15, 3 is common. So 3x plus 5. Here, between 15 and 25, they both could be divisible by 5. So what's remaining here is 3y minus 5. Now, here we don't have coefficient, we don't have number before the x squared. Then, but you see we have an x here and an x squared here. So it's okay to take the x out as a common factor because it's in both terms. Then x squared, if we take out 1x from it, only 1x remaining, because x squared is x times x, and 1x is out, 1x is remaining, plus the 7x, the x went out, only the 7 will remain. Question 7, this time we have a common number between 3 and 9, which is 3. And as you see, y is in both terms, so definitely y is a common factor. Now, if we take out 3y from this term, only y will remain, minus 9 divided by 3 is 3, and the y went out, because this y because this y is power 1 and 1y is out, so that's it. Here, 10 and 25 could be divided by 5. 10 and 25 could be divided by 5. Y is common, y is also out. What's remaining is 2y plus 5. Question 12. 3 is common between 12 and 15, and z is common. Well, we will have 3z out. 4z will remain here, minus 5. 15 divided by 3 is 5, and the z is out. Multiply 3z by inside the brackets. You see the exact same expression again. 4xy minus 10x. What is this xy? It's just a combination of two variables, but it doesn't affect the answer. Between 4 and 10, they both divisible by 2. X is a common factor, so x should be outside the brackets. What's remaining here is 4 divided 2 is 2. The y remaining, because only the x went out, minus 10 divided by 2 is 5. The x will not remain because the x went out. Changing the subject of a formula. When you want to change the subject of a formula, it means put the variable which is supposed to be the subject alone on a side, then you're done. Question 1, we have to make B the subject, then V is equal to A, B, C. How can we have B alone on a side? We need to get rid of A and C. The relation between A and C with the B is multiplication. The opposite of multiplication is division. So we're going to divide both sides by AC. Then here we will have V over AC that equals ABC over AC. Now in fractions, since there is no plus or minus with the fraction, we can simply cancel the common ones. So finally what's remaining is V over AC on this side, and on the other side is B. So whenever you see B alone on a side, it doesn't matter this left or right, doesn't matter. Now B is the subject of this formula. Question 2, we need to make Y the subject. Then we need to make the M subject. Then to make M the subject, we have Y equals mx plus c. We need to have M alone on a side. Firstly, we're going to get rid of this c. When it goes to the other side, it becomes negative, so y minus c is equal to mx. Now we need to get rid of this x. The relation between m and this x is multiplication. So to get rid of this x, we divide both sides by x. This one will be cancelled. This one will remain. Y minus c over x is equal to m. Now m is alone on a side, so m is the subject. Question 3. C is 2 pi r. Circumference is 2 pi r. We need to make the r the subject. Well, to make the r the subject, simply we just divide the c by 2 pi. C over 2 pi gives r. Now r is alone on a side, so r is the subject. Let's do question 5. It was question 3. Question 5. W is equal to 8h squared. We need to make the h the subject. Question 5 is more important because it has one step a little bit different from the previous questions. We need to have h alone on a side, then we divide both sides by 8. W over 8 is equal to h squared. We need h alone on a side, we don't need h squared. How can we get rid of this power 2? The opposite of power 2 is square root. Then by taking square root for both sides, w over 8 is equal to h squared under square root. And square root with power 2, they always cancel each other. What's remaining on the side is only h. And on the other side, since there is no power 2 to cancel the square root will stay. So that's how it looks. The square root of w over 8 is equal to h because the square cancelled the square root. This is question 5. Question 7. U is 2a plus n, so it's kind of similar to question 2. Well, question 7, u is 2a plus n. Then we need to have a as the subject. We get rid of this n first. It's positive. the relation between the n and the a is plus, so the opposite happens to the other side. U minus n is 2a. Then to get rid of this 2, we divide both sides by 2. That gives u minus n over 2 is equal to a. As you know, since in this fraction there is no plus or minus, we can just cancel the like terms between denominator and the numerator of the fraction. Now a is all alone on a side, a is the subject. Question 9, how can we make this r the subject? It's similar to question 5. Firstly, we divide a by pi and then try to get the answer. The answer is like this. You do the steps. A over pi under the square root is equal to r. This is the answer. You do the steps. It's similar to question 5. And the rest, question 4, 6, 8, and 10 are homework. Addition and subtraction of fractions is quite the same as addition and subtraction for algebraic terms like this. So let's do some of these. The first one, it's 1 over 8 plus 1 over 2. For adding fractions, we always need the common denominator. The common denominator between 8 and 2 is 8. How 8 becomes 8? By multiplying by 1, so 1 times 1 is here. How 2 becomes 8? We need to multiply them by 4 to get 8 as denominator. Then 2 times 4 is 8, 1 times 4 is 4. Now we have the same denominator. Yes, freely you can add them. 1 plus 4 is 5 over 8. Question 2. It's the same as question 1, but this time instead of ones, we have x's. Then we can straight away say it will be 5x over 8. Why? Because it's the same as this one, but this time we'll say x over 8 plus 4x over 8. X plus 4x gives 5x over 8. This one, the common denominator between 4 and 5 is 20. How 5 becomes 20 times 4 times 5. Then 3 times 4 is 12. 5 times 1 is 5. 12 minus 5 is 7 over 20. 7 over 20. What we have here, instead of 3 we have 3x. Instead of 1 we have 1x. And same denominators. Again, 20 is the common denominator, and we will get 12x minus 5x, that gives 7x. Question 5. The common denominator between 3 and 7 is 21, so 2y over 3 minus 3y over 7. The common denominator is 21. How 3 becomes 21 times 7 times 7 times 3 times 3. 7 times 3, 21. 3 times 7, 21. 2y times 7 is 14y. 3y times 3 is 9y. 14y minus 9y is equal to 5y over 21. That was question 5. Question 6. 7a over 10 minus a over 2. The common denominator between 2 and 10 is 10. We can also write one denominator. How 2 becomes 10 times 5. And whenever you multiply the denominator by a number, you must multiply the numerator by the same number as well. Then it's already 10. It means the 7a will not change, minus 5 times a is 5a. This is another way of writing, and it's fine. We just write one denominator. Mathematically, it's fine. 7a minus 5a is 2a over 10. Now, 2a and 10. 2 and a, they both could be divided by 2. So it means this fraction is not in its simplest form. The simplest form is a over 5. Because 2 and 10, they could be divided by 2. And whenever you see up and down are divisible by a specific number, you have to divide them to get the simplest form of your fraction. Question 7. The common denominator between 3 and 10 is 30. How 3 becomes 30 times 10? Times 10 here. Now 2b times 10 is 20b. How 10 becomes 30 times 3 times 3? 3b, and it's minus between them. Now 20b minus 3b is 17b over 30. 17 is a prime number, so of course there is no such number that can divide 17 and 30 at the same time. Let's do 9. Question 9. We have x over 8 plus x plus 3 over 2. The common denominator between 8 and 2 is 8. Then, this is already 8. The x will not be multiplied by anything. It stays as x plus how 2 becomes 8. So we'll have times 4 times 4. How 2 becomes 8? Times 4. And the whole numerator will be multiplied by 4. Now, 4 times 2 is 8. It's correct. 4 times x is 4x. 4 times 3 is 12. Now, next step, add the like terms. X plus 4x will be 5x. 5x plus 12 over 8. Can we divide this 12 and this 8 by 4? Of course, no, because there is an addition with it. Whenever you see addition or subtraction in the numerator or denominator, you cannot do any simplification, only if this number be even, only if all the numbers you see in the expression, if all the numbers you see, if all of them are divisible by a specific number, then you can do this simplification. For now, it's impossible to divide the 12 and the 8 by 4. No, because this 12 is not alone. It has 5x with it. Since we cannot divide the 5x by 4, it means it's impossible to do the simplification. Question 12. The common denominator is 2x. 7 over x minus 3 over 2x. The common denominator is 2x. How x becomes 2x if we multiply it by 2? So times 2 times 2. 7 times 2, 14, minus, this is already 2x, this 3 will not be multiplied by anything, 3. So 14 minus 3 is 11 over 2x. Can we divide 11 by 2? No, so this is the simplest form. Shapes, congruency, and geometric reasoning is for the next lesson. Thank you for watching.